Hello everyone and welcome to this video lecture. My name is Palash Path, a student at IAPHD ABB Indore, enrolled in Dr. Saligram Prajapat's class on numerical analysis and design. In this video, we will be going through the solutions of three question paper which was assigned by our professor to test our knowledge on the topic of numerical analysis. So let's begin.
Is the first question. In the first question, we need to write an algorithm to accomplish the task for the polynomial px given in the following table. The polynomial given to us is a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 plus a n minus 3 x to the power n minus 3 and so on up to a1x plus a0, and we need to calculate the algorithm for the following three tasks. The first task is evaluating the polynomial using the brute force technique or the iterative approach, and the second is the recursive approach. In the second task, we need to divide the polynomial px by x minus r, and the third task is to find the derivative of the polynomial px. So first, let's find the polynomial px using the iterative approach. In the iterative approach, we initialize the sum of the variable s to 0, and then we compute the value of a1, a0, a1, a2, a3, and so on up to an. And then we multiply each term that is a0 to its corresponding coefficient. That is a0 is multiplied to x to the power 0, a1 is multiplied to x to the power 1, and a2 is multiplied to x to the power 2, and so on it goes up to a n minus 1 is multiplied to x to the power n minus 1, and a n is multiplied to x to the power n, and then we store these values in the sum variable and then return it. As we have seen here, what we have done here is we have first read the values of x, n, and a, and initialized the sum to 0. And then we have here read the values of ai from 0 to n. So firstly, the value would be a0, a1, then a2, and so on up to an. And now what we have done is we have initialize the value of sum to 0, and then we have initialized the for loop. In the for loop, the range starts from n to 0, and then we have stored this sum. In the sum, we have stored sum plus ai into x to the power I. So the firstly the sum was 0, and then it would go and then it would go here as a0, then an x to the power n, and in the second iteration it would be an x to the power n plus an minus 1 an x to the power an minus 1 into x to the power n minus 1, and in the third iteration it would be an x to the power n plus an minus 1 x to the power n minus 1, and then an minus 2 x to the power n minus 2, and the sum variable would store this polynomial, and at last it would store an x to the power n plus an minus 1 x to the power n minus 1, and it would go up to a1x plus a0. This that is here we would get our desired polynomial px. And now let's see the recursive approach, how we would calculate the algorithm using the recursive approach for this polynomial. What we're gonna do here is we would make a function named polynomial, which which will take the values of n, x, and a. And if the polynomial is that is px, if the polynomial px is equal to a0, then we would just return it. As we don't need to add any further values to it, we would just return it. That is n equal to 0. That is a0. So we would just return a0 here. Else what we will do is we would return an into x to the power n plus we have called here the polynomial function again. This is the recursive algorithm. So we have called the polynomial function here again. So it would be a n if an x to the power n plus a n minus 1 x to the power n minus 1 plus the polynomial function. The polynomial function with the values n minus 2 would be here. N minus 2 would be here. And then it would go on till the n value is reached. So here we have read the values of x and n a, and we have initialized the sum to 0, and we have read the values of ai, that is a0, a1, a2, a3, and so on up to an, and then at the last we have called the polynomial function. So the polynomial function would be called here, and it would store the value of an firstly, then an x to the power n firstly, then an minus 1 x to the power n minus 1 in the second iteration. In the third iteration, it would store the value of an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2, and and so on. In the last iteration, it would store the whole polynomial px. So this is the recursive approach. As we have seen, what we have done is, if the degree of the polynomial is 0, return the value of the constant term as 0, which is this part. If n equal to 0, return a0. Okay, then we have otherwise compute the value of px recursively by computing the value of polynomial by degree n minus 1 by calling the function recursively with the polynomial degree n minus 1 as the argument. As we have seen here, we have made the function polynomial which takes value n, x, and a, and we have returned here a n x to the power n plus the polynomial function has been called again here till we have reached the n which was given input by the user, and and we have written the polynomial over here. So this is the recursive approach for calculating the algorithm for calculating the polynomial px using the recursive approach. So now the second point, the second task is dividing a polynomial by x minus r. So we need to find an algorithm to divide the polynomial by x minus r. So here's the algorithm for dividing px by x minus r. What we have done here is we have first initialized the quotient and remainder to 0. Quotient and remainder to 0, here it has been initialized. Then for each term of the polynomial from highest to lowest degree, each term of the polynomial from highest to lowest degree from I n equal to 0, that is from n would go from, I would grow from n to 0. From n to 0 we would go for the I value goes from n to 0, and it would go in a decrement order. Okay, so what we will have done here is, for each term of the polynomial from highest to lowest degree, compute the value of the term by multiplying, sorry, compute the value of the current term of the quotient by dividing the coefficient by x minus r. What we have done here is we are going to divide the ai. The first term has been divided using the x minus r. Here, for example, the ai, that is az, an would be divided by x minus r over here, and then we would add the computed value to the quotient of the polynomial. The computed value which we are getting from this part has been added to the quotient value. The quotient becomes q plus cq into x to the power I, that is a n x to the power 1, x to the power n. Okay, In the third part, compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. Compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. Okay, so we are here finding the current term by multiplying the quotient. The quotient that we got has been multiplied to x minus r, and then we have calculated the remainder. We subtract the compounded value of the current term from the polynomial. Subtract the current value. Here the current value has been subtracted, and then add the compounded value to the remainder of the polynomial, and then the value has been added to the remainder. This is the algorithm for dividing a polynomial using dividing a polynomial by x minus r. This is the algorithm. And the third one here is to find the derivative of the polynomial px, derivative of the polynomial px, that is we need to find of dpx by dx here, like dpx by dx. So let's see how we are going to do it. What we're going to do is we initially we would initialize the derivative of the polynomial d to 0. Here if we look, we have initialized the derivative of the polynomial as 0 over here. In this first three steps, first three steps, what we have done is we have calculated the values of ai, that is a0, a1, a2, and so on up to an. And then we have initialized the value of derivative as 0. And then for each term we have each term of the polynomial from highest to lowest degree, we will compute the value of the current term by multiplying the coefficient of the term by subtracting one from the degree. That is here if we see the ai, that is the current term, and we have subtracted one from the degree and then computed it. That is it would be a n minus 1. For example, I is n minus 1, then n minus 1, and then it would be bracket, it would be n minus 1 minus 1. So it would give us a n minus 1 to the x to the power n minus 2. And then we have stored the value in the d variable, which we have initialized to 0. So this way we will be writing the algorithm for calculation of the derivative of the polynomial px. So these were the three tasks that we needed to perform. The first one was the calculation of the evaluation of the polynomial using the iterative and the recursive approach. The second one was the division of the polynomial, and the third one was derivative computing the derivative of the polynomial using the px. So this finishes the first question.